Hi, my name is Henning. I'm data scientist at Kinetica, and in this video I'll explain how to integrate Kinetica with the Kinetica file system. Imagine you've got a large amount of data, like for example images, on the cluster where Kinetica is running already. If that's the case, then there's no need to actually ingest that data again into tables. Instead, you can mount that file system to Kinetica, and the data is directly mirrored into a table. In this video, I'll explain how to configure and set up the Kinetica file system, and then walk through various ways of accessing that data. First thing you need to do is edit the GPUDB.conf file. You need to set this variable to true, which tells Kinetica that you do want to use the Kinetica file system. And then you also need to tell what directory you do want to mount. After that, you need to restart Kinetica to take these changes, for these changes to take effect. And then you can start copying files into that directory that you have mounted, unless that directory that you have mounted already contains all the files you want to use. And that, for example, could be image data that will then show up in a Kinetica table. There's also documentation about this with more details. So feel free to also have a look at that page. Now, once you have mounted your data, you'll be able to browse the table that mirrors that folder here in GAdmin. So one possibility is under tables, there will be a collection file system, and within that collection, all the folders that you have mounted under your root that you have put into your root mount folder will show up here as a table. So for example, you can see here, I do have a folder KiFS, mnist sample, and that folder here shows up as the name __ KiFS, and then the actual folder name, that is the file name that mirrors that folder here in Kinetica. Now, however, browsing that data under tables and then in that collection is actually not recommended. Instead, the recommended way doing this is here the KiFS browser, where you have also access to all your subfolders. And you can browse through that data here and, for example, also download single files if you need to. Now, a much more interesting way to access the data is actually through the various APIs that you could use in Kinetica. One way would be to use a distributed user-defined function. And that means if you do that, if you have a distributed UDF, that possibly there will be running multiple instances of that UDF across your cluster. And it also means that each instance does access the data of their respective TOM of the machine where this UDF is running, right? So that means each UDF handles a fraction of the overall data. The way you access the data through a distributed UDF is through the proc data handle. So you can see that in the little code snippet here. You have access to the proc data handle. There you tell what is my table that I want to access. So there you point to the table that mirrors your KiFS folder. And then the data that you get from there will be raw binary data. So you also need to take care to manually then turn that back into actual image data in that example. So that is through a distributed UDF. Another possibility is actually to access the data also through a distributed or through a non-distributed UDF, but not through the proc data handle, but from the file system directly. You just need to keep in mind, if you do that, then the locality of the data is not guaranteed anymore. Instead, each instance of the UDF does access the entire data. So that means if you have multiple instances running, in case you have a distributed UDF, that you manually need to take care of the division of labor, meaning that you need to take care to handle what UDF is actually processing which fraction of the data. An advantage of using KIFS directly is that the access of the data is really fast. The way you would do that is, well, you use your proc data handle again, but not to access the actual data, but to get the necessary information about where is actually your mount point, right? Where's your folder with the data? So that's something you can get from the handle, but then reading the data is through the common Python file system API here, for example. And then you could also use the Python Gui Db Api, which is different from the UDF API, and that allows you to actually have SQL-like filters, for example. And the way that would work, well, you would have your GPUDB handle like that. So this is a different way from the UDF API. This is the GPUDB API. You have your handle, and there you tell what's my table name, how many records do I want to read, and what's the limit. And then here, in this example, there are no options, but this is where you could put in filters, saying I want all the rows where, for example, the size of my images is less than a certain value, right? This is something you could do here with that API. Then what you get back is, again, raw byte data, so you would have to convert that back into images again. However, all of this is not really recommended because accessing the data that comes from KIFS in that way is actually pretty slow. Now, this was a lot of information about how to access large amounts of image data. A use case where you actually may want to do that is through TensorFlow image classification. If you're interested to do that, you may also be interested in my other blog post about the mechanics of how to bring together Kinetica and TensorFlow.